Questions?
That's brutal.
No. Is it possible to put that on one dial instead of having multiple?
Multiple tweaks, you mean?
Yeah. Because I mean, if you go into a retail store, you put that into a retail store.
It would. Yeah, that's the whole thing.
That's the whole thing. They're gonna want it on one dial.
That's right. That's the idea of replacing the analogs with the
Arduino board, so that would compensate automatically for help speak energy.
and I believe those three tweaks allow different weights to be levitated at different heights. And so in other words, as I would tweak the gain on the circuit, the thing goes up or down in the field with the same weight. But then the other two tweaks were, other two potentiometers were controlling the amount of current for that particular object, and which would mean you could put a heavier object. So anyway, it's very interesting, and advertisers are definitely interested if it can become a working product. And in fact, in this notebook of the old Once Upon a Time, there is.
So you said Once Upon a Time was 2003?
It started in the 1990s, early 1990s.
Local or?
In New York City. So this was something that somebody had, and they had Nike interested, and they worked up this kind of advertising idea. But the amount, it was actually floating, but you could barely see that it was floating. It might have been holding on a string, you know. So then the idea is to boost the power or boost the distance so it's more observable. And so it really makes a big difference. If you have some obviously heavy object floating even one more inch, it's just a lot more impressive. So that's the limitation, one of the limitations.
So you're going to continue with this?
I'm definitely going to continue with it. Anyway, it's the first page. Oh yeah, this is the first couple pages of this guy's doctoral thesis, or a few interesting pages. But it's 2009, and especially this page. Those are all the big companies that funded his doctoral thesis.
What's his name?
So this is really a big deal. His paper is very interesting. I'm going to read his paper, and this has a lot of solving these particular difficulties is really a big deal in the computer age.
From the magnetic standpoint?
From the current mode control of the power. The digital current mode control of the power. And so there's various advantages that current mode control has, but then there's various problems that come up as well. And so in his paper, there were 5 different models by which people were thinking this is the proper way to approach this. So this particular guy did a pretty extensive research on what had been done and how people had tried to solve the problem. And as we become more interested in just greater and greater manipulation of power in many different devices, and this is actually a cutting-edge topic of current mode control of high power by digital means.
So what got you into
background-wise? Myself, background-wise, pretty interesting. I started out at the Resident Polytechnic Institute way back when. I did a year there, and but then they really weren't interested in studying physics for the same reason I was interested in studying physics. And so I was ahead of my time, it turns out. And so I did other things for 10 years, and I became a machinist, and then I became a computer programmer. And then I was asked to participate in a radio frequency startup company from the same organization. This led to me actually inventing a component that at one time it was Northern Telecom, AT&T, biggest telecommunication companies in America and Canada were all buying this component from us. And they said, and it was only, we unfortunately didn't patent it because middle management didn't, they dragged their feet. But it was very interesting. We never advertised that component. These telecommunication people were saying to each other, the only place you can get this is this company that I work for. And even then, there was a world expert, Randall Rhea, who invented Eagleware and owns Noble Publishing. I went to one of his seminars, I tried to explain this to him, and he walked away angry, saying, I believe in the laws of physics. But 6 years later, he published an article that 6 years later we thought, our business is going down, why don't we reveal the secret? And so even 6 years later, then in fact, just by accident, called the wireless magazine that Randall Rhea owns and was a technical editor for. So he was reminded of our previous meeting, but now he believed me because he knew our consultant. And so I'm somebody that if I had the ITT-Tech or typical engineering background, I would have thought, I'm not going to try to make this component this way because it's not going to work. So I wouldn't even have attempted what I did to invent that thing. But this kind of experience tells me, look, there's like, people like to think they have a handle on things, but there's a whole lot of things that people do not have a handle on those things. And like various components, they're usually, the manufacturers test them only under certain circumstances. Suppose somebody wants to use it in some area that the manufacturer never tested it. And turns out a recommended component for a completely different frequency is the best one for this unsuspected other thing. And so this kind of thing happens all the time, and it happens with people like me get their hands on these components and try them out in the applications. And so that's kind of the background that I'm coming from, and that's why I'm interested in this. And especially after ITT-Tech, it filled in my electrical background knowledge. It filled in the theory. And so I'm actually very grateful for ITT-Tech. I mean, I appreciate the level of the teachers here. And I mean, a lot of times I get 100, and I would consider my life circumstance, having a family and needing to go to school at night. And so I appreciate ITT-Tech very much. And appreciate it. It's a lot of fun.
You hear that, Mr. Reynolds?
You're welcome.
Appreciate it.